Let's look at Chapter 3, Numerically Summarizing Data. Section 1 is on measures of central tendency, or measures of center. So the first thing we will look at is the mean. So we just simply compute that by adding up all the values of the variable and then dividing by the number of observations. So typically when we think of the mean, we think of the average. But the reason we do not use the term average is different fields may use a different meaning for average. And so we just want to clarify that we're using the total of all the values divided by the number of observations. So we're getting into some symbols here, so you may want to jot these off to the side, write down what they are, and then keep that running list. We're going to use different symbols for population and samples. So before, remember, we used capital N for a population and we use lowercase n for a sample. So typically we're going to use Greek letters to represent population and English letters to represent a sample. So the first letter we have here is for the population mean, and that's the Greek letter, the Greek lowercase letter mu. And the population mean and the sample mean are computed the same way, they just have a different representation here. And since the population mean is going to be a numerical summary of a population, it is a parameter. So you can see there's the symbol notation. So we have mu is equal to, we just have our data values, and there's the capital N. This is the Greek letter sigma, the capital uppercase letter sigma there. So that just means to sum up. So we're summing up all the x sub i's there. And then our sample mean is x bar. And that's computed using sample data, and it is a statistic, right? Because it's a numerical summary of a sample. So you can see the same formula there. Instead, we have lowercase n's. And we'll go through some examples in more detail later on. So you can see the computation there by hand. So the median is another measure of center. So our first one is mean, the second one is median. So that is the value that lies directly in the middle when the data is arranged in ascending order. So by ascending order here we mean smallest to largest. And we'll use M to represent the median. The calculator uses MED for median. And then you can follow these steps. We're going to find these using technology. These are the step by hand. We're going to go through some examples. So I'm just going to skip through this. So what happens when we have an extreme value? So you can see we have some employees here, and then we add an employee who's got a commute time of 130 minutes. So that's a value that's way out. So we see here that after we hire that employee, the mean increases a significant amount, but the median only increases a little bit. So we can see that that extreme commute time greatly impacts the mean, but only has a slight impact on the median. So this brings us to the next definition. A numerical summary of data is said to be resistant if extreme values relative to the data do not affect its values substantially. So that means that the median is resistant, but the mean is not. So you're going to keep that in mind. So here's the relation between the mean, median, and distribution shape. So this is going to be important. Key thing for your Chapter 3 lab in interpreting that. So you want to make sure you're using that information. So when the mean is less than the median, our data is going to be skewed left. When they're approximately equal, it's going to be symmetric. When the mean is greater than the median, it's going to be skewed right. So when it's skewed right, the tail's on the right-hand side, skewed left, the tail's on the left-hand side. This is not always true. Typically, discrete data are going to violate this. This is just some guidelines. It's an example here. And then the last measure here is mode. So mode is just the value that occurs the most. Sometimes we may have a set of data that has no mode, so that would mean all the values are just represented once. may have one mode, so this one value is represented more than once, and then more than one mode, so if we have 2 modes, it's bimodal, and then 3 modes or 4 or so on, we just say multimodal. So that kind of sums up the 3 different measures of central tendency, how we compute them, their interpretation, and what to use. Or I guess that should be when to use there. So we want to use the mean when our data is symmetric. We want to use median when our data is skewed, and mode when we're looking at data that is qualitative. Or for some reason, the data value that occurs the most is the desired measure there. So I think that sums up 3.3.